In this little introduction here, we'll just introduce vectors very briefly. We are in the class going to focus on predominantly two different kinds of quantities. These are scalars and vectors. A scalar is a physical quantity that can be described by a number only, and usually a unit, of course. For example, temperature. If we say the temperature outside today is going to be 100 degrees Fahrenheit, then that sentence makes sense. That quantity, this is the temperature, is a scalar. We can also talk about a car traveling at 75 miles per hour down the highway. That sentence makes sense as well. We have a number and a unit, and nothing else is needed. That's what we call speed. We could also say that the car is traveling 75 miles per hour north. Now we have the number, we have a unit, but we also attach a direction to it. So that's a different quantity. We call that quantity for velocity. And that's an example of a vector. So a vector is characterized by a direction and magnitude. We need both to specify a vector. So we're going to see a variety of vectors like forces, momentum, torque. These are all examples of vectors that we're going to encounter in our class. We do have some quantities that are not scalars and not vectors, but higher order vectors, if you wish to call them that. They are called tensors. We're not directly going to deal with tensors in this class. I think, at least in America, you are often, at least the introductory classes, you are really afraid of, or the instructors are afraid to use tensors. But we are going to use components of a tensor. For example, a moment of inertia, which is a resistance to a change in motion, a change in rotational motion, is an example of a tensor. We're going to use a component of it. We are going to talk about pressure. Pressure is also a component of a tensor. We call it stress tensor. So I'll point out as we get to those parameters or quantities that they are components of tensors. And we will see why they are in fact components and not the truth. So keep in mind that we're learning a lot of things in Physics 2210, but we're not telling you everything. We're leaving something for later. If you are in engineering, you will, particularly mechanical engineering, you will definitely get to work with those tensors, specifically the stress tensor. But instead, you may not see them actually as a tensor. Instead, they may be represented as a matrix. All right. So we have two ways we're going to represent our vectors. One is geometrically, and the other is analytically. And here I want to show real quick how we can represent them as a geometrically way. So in a geometry sense, we can call a vector a directed line. A directed line segment, in the sense that if we take an initial point and a terminal point or final point, and you draw a straight line between the two, and you indicate a direction from the beginning to the end, then we have a directed line segment, and that is our vector between those 2 points. So that's represented here by the blue arrow, is a directed line segment. But keep in mind that a vector is just defined, or you should say a true vector is defined only through its magnitude or its length and its direction. So if I take a second vector and draw it somewhere else, but it has exactly the same length, exactly the same direction, just because I drew it somewhere else doesn't change the nature of the vector. The vector is only characterized by its length and its direction, not by where it's located, at least for a true vector. So in this example where vector A, which is blue, and vector B, which is red, those both have the same length, same direction. Those two are indeed identical, despite the fact that they draw in two different places.